Hello everyone and welcome to this EasyEO tutorial series. EasyEO is a Python library that has been developed for Earth observation analysis. It helps you to do Earth observation analysis in an easy way. That means that you don't have to worry about all the technical complexities that you have to take care of when using low-level libraries like Rasterio. EasyEO keeps track of all those complexities for you so that you can focus on the analysis itself. This is the documentation, and this is the GitHub repository for those of you who are familiar with GitHub. You can scroll down and go through the repository. I will appreciate also if you give the repository a star. You can see here that it has been tested across the 3 platforms: Linux, macOS, and Windows, and then also tested across all these versions of Python. I will leave the link to the repository and the documentation in the description so that you can read further if you are interested. But for now, let me take you into Visual Studio Code and show you what this library does and how it does it. This is Visual Studio Code, and this repository also is linked in the description. You can see it here, the EasyEO tutorials. That is also this repository. I will also appreciate if you give it a star. I also have QGIS opened. We will need it along the way. But now let me come back to Visual Studio Code. I have 2 files here opened, one called real.py and one called easy.py. They show a very simple workflow in Earth observation, but with a traditional Rasterio approach and an EasyEO approach. I try to make this script as simple and as short as possible while also keeping everything that it has to do in check. So what this script does is it fetches a raster file from a hosted Sentinel-2 data, which is part of the EasyEO releases, and then clips it to an area of interest, and then performs all the node data checks and validation, computes NDVI, updates the profile of the raster, and then writes the raster2 file. So you can see here that I do not have those files here. So if I go ahead and run this, in my terminal cd into, and then I go Python real.py. It has run successfully, and you can see the NDVI here. But this is the same workflow in EasyEO to the right. This sample data set can also be accessed in the library like this. You can, of course, also load your own raster data sets, but this is for the tutorial. And then once you load the data sets, this is one line, but to just make it nice, I just broke it down to several lines. And in this single line, you are loading the raster, and you chain the clipping operation on top of it. You also compute your NDVI, and then you go ahead and save your raster. All these functions also, like the clip raster, the NDVI, the save, they can also be called independently and used. You don't necessarily have to chain your operations. But EasyEO also introduces the chaining so that your workflow can be simplified and faster as well. I'll go ahead also and run this EasyEO. So Python easy.py. That is also done. And if I check, you should see that there's now another file called NDVI EEO. I'll come to QGIS here. I have them. I can drag this, and then I drag this one too. You can see that there's no difference between the two. They have the same minimum and maximum. You can see it here. And if I check this one off, it looks like nothing happened. That is because these two, they are producing the same output. They have the same shape, the same CRS, the same transform, the same node data, and every single one of the pixel values are the same. But the point here is not the line count, not just because EasyEO can do it in a few lines of code. The point is that with Rasterio and other traditional libraries, you have to take care of a lot of things and make sure that you do all of them right. And there are chances that if you fail to do it right somewhere, your analysis might crash or produce inaccurate results. You have to make sure you take care of no data, mask it out, so that in cases where, for instance, you are now computing NDVI, if you don't mask out the no data, some pixel values might come out as 0, which you will think is the ground or background, but actually it's not background, it's no data that you forgot to mask out. Also, if you forgot to update the profile information of the raster, it will also save a raster with an inconsistent metadata. EasyEO takes care of all of that for you so that you don't have to worry that you did something wrong somewhere. And also, there is this tutorial notebook for getting started with EasyEO. It is also part of the repository, and the sweet part is that you can run this in Colab directly without having to install EasyEO on your system. But if you want to run it locally, you have to watch this video or check the installation instruction that shows you how to install EasyEO on your system. Then you can run this notebook locally. But for now, let me come to the repository and then let's run it together in Colab. So this is the same notebook. What I'll do is to click open in Colab here. And now, if we are supposed to run in Colab, we have to uncomment this line to install EasyEO. Once again, you can watch the installation video to know more about what this EasyEO stack means. So I'll run this cell. I have to trust it. It has successfully installed. And in this cell, we are loading the sample data we saw at that place again. So I will load it. You can also, of course, load your own raster with the load raster by passing the path to the raster. But EasyEO objects also come with a describe method that you can use to describe your data set. So if I run this describe and say stats equal to true, it will give me a description of the raster and then also a band by band statistics of all the bands in the raster. If I take away this stats equal to true, I'll only get a description without a band to band description. But with this, I get band to band description with the dataset description itself. And also, this is a very small raster file, so you get exact full read even if you pass approximate or true. But if you are dealing with a very large raster, you want to pass approximate or true like I've passed. What it does is it gives you a quick statistics, not a full read of all the bands. So you can have an idea of what it is, but if you want the exact statistics, just pass exact and then it will do that for you. Now, this is NDVI in one line, which is you are calling the scene. EasyEO, like I showed you before, the methods are designed to be called independently, or you can also chain the methods if you want to. So this scene is the file here that has been loaded. And then we are performing NDVI on it. And here we call the red band as red and NIR as NIR, but you usually use one based indexing to select your bands. EasyEO allows that also, but also it tries to make things easier for you. In that case, you can pass band names which will be assigned to the bands at read time. And everywhere in your code where you have to refer to the blue band, you don't have to use an index of 1. You can just call blue like we have done here. So if you give a name also to the data set, it can also be used and called somewhere. which is also a useful thing. If I run this, the NDVI has been performed. I can plot it by calling plot raster on the object, and it will plot my NDVI for me. So this is the NDVI. You can see that this name that I passed here has also been added to the title, making it descriptive enough. Also, if I want to get a color bar, I can just pass a color bar equal to true. Color bar equal to true, and that will give me the color bar as well. If I don't like this title of the color bar, what I can do is to pass a color bar title, a color bar label, sorry, and say maybe NDVI values, and it will change it for me like this. Okay. This is also an example of a full chain operation in one expression. So I have an area of interest here, a bounding box. I want to clip this scene up here to an area of interest. This area of interest has been selected to be inside the scene itself. After clipping, I want to resample to a scale factor of 2. Of course, you can resample by many other methods. Subsequent tutorials will explain them. And after the resampling, I want to compute an NDVI of the resampled data. And then after the NDVI computation, I want to perform a percentile normalization on the NDVI and then plot the raster. Well, this particular expression is not selected for any real case or real world scenario, but just to show you that this is how easily you can change your methods and perform the operations using EasyEO. Traditionally, you may have to write functions for each and every one of these and then call them, which, as I said before, you have a lot of things to make sure you do right. So I'll run this, and then this plots it for me. But of course, I did not pass a lot of things to this plot raster. That is why it is using the default gray. You can pass them in, and it will take it for you. Also, for each of the plot raster, you can also see that it has a save path, which means that if you add the save path inside the plot raster function, it will save the plot to that particular file for you. So if you want to save the plot, it is as easy as that. And it also has some built-in indices. So I have here a few examples of the built-in indices. It also has a general normalized difference method you can use to compute differences which are not here. This one also is calling the same scene. There's NDVI past the red and the green, and the EVI and all the savvy. What I'll do is to run this cell, and you see that this has plotted all of them. Of course, it got all of them and gave them to Matplotlib, and Matplotlib has plotted all of them for us. Well, each of the index above is its own single band data set, like this comment is saying, so we can use EasyEO to stack them into a multi-band EasyEO raster data set. And then plot raster can handle multi-band data sets so that we don't need to do all this Matplotlib plotting by hand. So in this scene, you can see that a new data set is being created called stacked, and it is stacking the indices, ndvi.stack. Then this stack method can take in one or more EEO raster data sets. And once it stacks them, we can do the plotting as well. So I will run this cell as well. And then it has plotted them for me here. You can, of course, also pass the color bar equal to true, or in this case, even specify the number of columns you want the plot to be. So if you have a multi-band raster of maybe 12 rasters or 13, 20 or 4, 5, 6, you can specify the columns to make sure they are nicely distributed the way you want it. So if I put 3 here, I'm not sure how it will look like. Maybe nice, maybe ugly, but I can now confidently put back 2 because it makes it look better, because it's 4 items and it's just distributed 2 by 2. Also, it's EasyEO allows you don't have to fetch or download your own raster locally before you can use it. If you have an area of interest, all you need is to make sure you have installed the Stack Extra, and then you can get the satellite image for any area by using the EEO stack search method. So here, this stack search method is downloading a Sentinel-2 L2A image of this bounding box, and the date time is from 2023 June to August. Specify the cloud cover and a limit of 1, meaning that I should return 1 image. If you don't specify a limit, it might return so many files. And so I will run this. It has fetched it for me. So let's see what this thing brought. So in this same results is a list of images. So here we specify that we want the first item in the result, and this one does not really fetches the data. It doesn't download them immediately, except you call the load, which will load the specific bands that you are interested in that particular scene, so that you don't end up downloading so much data than you need. So in this particular instance where we want to compute NDVI, we are only loading the band 4 and the band 8. And so I'll run this cell. You realize that it took some time because now I had to fetch the band 4 and the band 8, but it has fetched them, plotted our NDVI for us. The same scene, I want to now load band 3 and band 8 to plot my NDWI. I can do that also by running this, and it has also fetched it for me. And this can be any valid bounding box of any area. For instance, this tool that can let you create bounding box, I've also linked it in the description below. I already have this bounding box from somewhere in Canada. I can just copy bbox, this one, and then come in here and then change this bounding box and then run. It will fetch again, and then I can recompute my NDVI, and I have my NDVI of that area, and you can see it's the same area, just like that, by passing a bounding box. And I can also do the same for the NDWI as well. And another thing is that you don't only have to pass a bounding box. If you have, let's say, a shape file or a vector file of your area, all you have to do is, instead of bbox, use another parameter called intersects. And then in here, you can pass your area of interest. So your AOI vector file. Once you pass the path to the file, EasyEO will look for the scene which intersects your area of interest. So this is an introduction to EasyEO. I hope you liked it. Thank you so much for your time, and until next time, it is goodbye.